In this lecture, we will discuss the reading brain. What happens in the brain when we read? And what are the implications for reading instruction? In Chapter 4, Seidenberg outlines our understanding of reading from eye tracking research. Seidenberg tells that reading is primarily a linguistic experience, employing knowledge that is shared with speech. However, the nature and arrangement of the visual symbols on the page, coupled with the fact that they are perceived by eye rather than ear, give rise to some characteristics that are specific to reading. Reading is accomplished by a visual system that evolved to solve other kinds of problems, recognizing faces and objects. Reading has not existed long enough to evolutionarily reshape the brain. Humans invented reading relatively recently, and we build a reading brain on the circuits set up for learning language. We recycle some of the circuits in the brain used for vision and language for the purpose of reading. The circuit we use for recognizing letters was previously used for recognizing faces. As Dr. Dewan explains, this sometimes causes challenges that need to be fixed for reading. The innate feature in our visual circuitry known as the symmetry mechanism that is very helpful for recognizing faces, regardless of their orientation. So if I see my mom's face to the side, face on, upside down, in partial view, etc., I still know it's mom. But this innate ability causes problems in letter recognition. A B must have the circle to the right, because if it is to the left, it is a D. And if you turn it upside down, it is a P. This problem can be seen in young children's writing their letters backwards or mirror writing, and it is the result of using a part of the brain in a novel way. Reading is processed in the brain, not the pupil. As we have talked about, this is why visual therapies will not help reading concerns. But reading does begin with a visual stimuli, with the exception of Braille, of course. So the visual system does impact reading. Eye movement research has been helpful in understanding the lower level, seeing part of reading, and also how reading is processed in the brain and connected to our thinking as we read. From eye movement research, we can see what readers do when they read. As we read left to right in English, our eyes make brief pauses, fixations, before jumping to the new pause, saccades. Also, our reading is not smoothly moving from left to right, but is full of regressions to previously read words. This regressive eye movement is common even in skilled readers. From eye movement research, we know that humans can perceive about 20 letters at one time, but not equally well. Only about 4 letters to the right and 3 to the left can be identified clearly, with letters further away becoming more and more fuzzy. However, the information of fuzzy letters is still important to help the reader know where they might next fixate. The number of letters that can be taken in at one time is constrained by both our perceptual visual field as well as our processing ability. Reading is a demanding task. The amount that we can see on a fixation seems pretty well matched to how rapidly we can make sense of it. When we read, our brain processes each letter, just some in parallel and in rapid duration. Fixation duration depends on difficulty of the word, difficulty of the text, how closely the text is being read, and the skill of the reader. We fixate on almost all content words at least once, some twice if it is a longer word. Small function words such as a and the may be skipped, not fixated on at all. But this does not mean not read, just that they don't get their own fixation. In Chapter 4, Seidenberg also outlines how speed reading is not an effective technique. Too much information is lost, and it encourages people to change reading in a way that inhibits comprehension, the whole point of reading. 3 ways speed reading ineffectively changes reading are: 1. It requires the reader to take in more visual information at a time. As we have already talked about, we can't process or understand more visual information that is taken in. So in this case, more is not better. Second, speed reading seeks to eliminate subvocalizations. Subvocalizations activate the phonological code of a word. Phonological information aids in understanding of orthographically similar words. It is important information for comprehension, and it is something skilled readers do and poor readers struggle with. Speed reading also seeks to eliminate regressive eye movements. Eye movement regressions in reading are also imperative for comprehension and seen in skilled reading. Once we have learned the code, how do we speed up reading and become more efficient readers? Read, read, read. Read a variety of texts to build your knowledge about words, language, and information. Reading follows a predictable developmental pathway. Yes, some children learn it more quickly than others, but they all learn the same basic skills of reading. As Duan told us, when it comes to reading, we all have roughly the same brain that imposes the same constraints and the same learning sequence. So now I want to turn to looking at the parts of the brain involved in reading and how the brain processes reading information. This information was discussed in the Dr. Duan lecture and video, and you will read more about the reading brain next week in the Seidenberg book. In order for reading to occur, several major regions of the left hemisphere of the brain must perform specific jobs in concert with others. As they read, good readers activate highly interconnected neurosystems that encompass regions in the back and front of the left side of the brain. Reading calls on many parts of the brain: vision, sound, auditory, meaning, memory, etc. Problems with any one of the subsystems can lead to reading difficulties. There are 4 key areas to know about. As described and shown in the Dr. Duan lecture, reading begins in the back of the brain with visual input that quickly moves to the occipito-temporal area, or word form area. This is described as the hub of the reading system and is also called the spelling box or letter box. This is the major locus of orthographic knowledge. The second key area is the angular gyrus, located where temporal, parietal, occipital lobes meet. This is a key convergence of meaning, phonology, and orthography. The third area is Wernicke's area. This is the language comprehension center, processing context and meaning. And the fourth key area is Broca's area, located in the frontal lobe, and is the speech center of the brain. How does a reader connect these different areas of the brain to read? Dr. Duan talks about 2 reading networks or circuits. Reading begins with the visual stimulation in the back of the brain, noted in blue, the visual inputs processed in the occipital lobe. This quickly moves to the area that recognizes visual words, the visual word form area, letter box, or spelling box. And from there, at least 2 networks are activated. 1, the network that connects meaning of the words, noted in green. And 2, the process that activates the pronunciation of the words, noted in orange. The human brain has an amazing ability to be flexible and create new connections throughout life. Cells can regenerate themselves and are plastic. It also has the capacity for automation, crucial in reading. As we learn to read, we rearrange our brain. Unlike language, there are no specific genes to dictate the circuitry for learning to read, nor a specific part of the brain used for reading. Our brain must connect older structures for vision and language to learn to read. With strong explicit instruction, we can change how the brain processes information. In this example, you can see that before the intervention, the child who was struggling learning to read was processing reading information primarily on the right side of the brain, with very little activation on the left, inefficient reading. After intervention, they were processing information much more efficiently. The good news is research-based instruction has been shown to alter brain functioning in children who struggle with reading, including those with reading disabilities. The key is explicit instruction of all aspects of reading, direct, systematic teaching of all aspects of the sounds of English, ample repetition and practice to assure learning to mastery. Effective instruction in K1 leads to significantly fewer problems in third grade and thereafter. Like a clear path through a large open field, explicit instruction on the sound structures and meaning structures of reading builds strong, direct neural pathways in the brain.